This is the Forth and Clyde Canal in central Scotland. Completed in 1790, it was the first canal to cross any part of the British Isles. There are a lot of geographical terms for coastal features where the sea indents into the land: sounds, inlets, fjords, locks, coves, bays, and so on. They all have subtly different meanings that can vary by location, but in Scotland, a lot of them are called firths, and they're pretty important when it comes to navigation. The Forth and Clyde Canal, as its name strongly suggests, connects the Firth of Forth to the Firth of Clyde. It also has a branch into the heart of Glasgow. When it was built, this canal dramatically shortened the transit times for goods in the region, and it also served as the testing waters for the very first steam-powered boats. Not long after the Forth and Clyde opened, another important canal was completed in Scotland. The Union Canal connected the cities of Falkirk and Edinburgh, opening up a route for coal and other minerals from the mines and quarries around Lanarkshire to the capital. Along the way, it passes over some pretty impressive aqueducts, including the Avon Aqueduct near Linlithgow. A connection to the Forth and Clyde Canal in Falkirk would provide a direct waterway link between the two largest cities in the country, Edinburgh and Glasgow, without ships needing to navigate the hazardous Firth of Forth. But there is the challenge of elevation. Union Canal sits about 115 feet or 38 meters above the level of the Forth and Clyde. Moving people and goods by boat has a lot of advantages. It's cheap, it's efficient, it usually takes less infrastructure, and it allows for connectivity across the globe, but there is a major disadvantage. The waterways that ships and boats traverse have to be pretty much level. Boats don't climb hills like cars, trucks, and trains. This is the main purpose of a lock: raising or lowering a vessel to navigate elevation changes in waterways. In fact, locks are pretty much the only solution to this engineering challenge, except in a few rare cases. You've seen the title, you know where I'm headed with this, but the story of the Falkirk Wheel, the only rotary boat lift in the world, is fascinating. Not just because of the mechanisms, but also how it came to be in the first place. It's not easy to accomplish projects like this. The Falkirk Wheel is not the passion project of some lone eccentric billionaire. This is public infrastructure, which means a vast array of stakeholders had to come together and agree that this bizarre structure was worth the resources that went into building it. It's got some very clever engineering under the hood and a lot of lessons in its creation that I think apply to other challenges we face today. I'm Grady, and this is Practical Engineering. Of course, the original connection between the Forth and Clyde and Union Canals did use locks. A lot of locks. This map from 1898 shows the flight of 11 locks required to get boats up and down between the two. You can imagine the time, resources, and effort involved in navigating this staircase. The process took the better part of a day, and not only that, it used a lot of water from the Union Canal. Even though boats can move through locks in both directions, water only moves through in one. Each structure always fills from the upper canal and always drains to the lower one. That's just gravity. But it's important to realize that even though most locks don't use pumps, the energy required to raise and lower boats through isn't free. Each passage through costs roughly one lockful of water from the upper canal. In addition to the inconvenience and water usage, other factors eventually drove these canal systems in Scotland into disrepair and abandonment. The canals were small, and as ships got larger, the narrow and shallow passages became less useful for transporting materials and goods. The railroads also started competing with the canals, offering faster connections between major cities. By 1930, the canals were barely used, and by 1960, they were choked with vegetation and debris. Motorway construction disconnected several segments, and authorities decided to close them for good. That could have been the end of the story, and honestly, it wouldn't be too surprising. It's been the fate of many of the world's great canals and inland waterways as transportation technologies and overland shipping have passed them by. But then the year 2000 happened. Maybe you remember this, it was a weird time to be alive. There was this strange tension between excitement about the new century and fear that all our computer systems would crash into an apocalypse. The programmers and IT professionals took good care of us on the computer side, but there were people working hard on the celebrations too. One of those organizations was the United Kingdom's Millennium Commission. The idea was simple: take some of the money from the National Lottery and direct it toward interesting and impactful projects that would help mark the turn of the century. In Scotland, a large consortium of organizations, public, private, and volunteers, got together and applied for a grant from the Millennium Commission. In 1997, funding was awarded to cover approximately half the cost of the Millennium Link, a massive undertaking to revitalize and reopen the canals that once connected Scotland from coast to coast, restore locks, build hike and bike trails, and rehabilitate bridges. The work included the Kelpies, a sculpture of two huge horse heads that serve as the gateway to the Forth and Clyde Canal. That was a pretty fascinating civil engineering project in its own right. But of course, the Millennium Link's flagship project was reconnecting the Forth and Clyde to the Union Canal. But rather than do it with locks, the group wanted a 21st century landmark. Or, I guess, more of a watermark. A fast, efficient connection that would serve as a capstone to the canal revitalization, draw tourists from around the world, and serve as a symbol of the region that was once a hub of transportation and commerce in Scotland. And in fact, the hub is a good metaphor for what they came up with. The Falkirk Wheel opened for traffic in May 2002, and now, more than 2 decades later, it's pretty clear they nailed the idea. Here's how it works. Boats bound for the Union Canal enter a circular turning basin at the bottom. The wheel has 2 opposed arms, each with water-filled gondolas or caissons spanning between them. Those gondolas are mounted on bearings that ride on circular rails. When one goes up, the other comes down, so traffic can move in both ways. The wheel is driven at its center using hydraulic motors that keep the motion smooth and slow. Idler pinions mesh between 2 identical ring gears, one fixed and centered on the shaft, the other surrounding each gondola. This arrangement enables the gondolas to counter-rotate as the wheel moves, maintaining their perfect upright position throughout the full range of motion. The elegance of the Falkirk Wheel hides some fairly complicated systems that make it function. At the top and bottom, each gondola has to be able to open and close to let boats in and out. And the aqueduct at the top needs the same capability so water doesn't just flow off the edge when the wheel is moving. The docking and undocking procedure is a delicate dance. When a gondola reaches the top position, stow pins extend to lock it in place. Then, an extendable lance connects it to a hydraulic power unit. A U-shaped seal extends to bridge the gap between the 2 structures, and pipes fill the gap between the gates with water, balancing the pressure. Finally, hydraulic rams open the gates on both sides, allowing boats to enter or leave. The whole process happens in reverse, and then the wheel is free to move again. Part of the engineering genius of the Falkirk Wheel is that it's always balanced, whether there are boats inside the gondolas or not. This is one of those confusing things about buoyancy. A floating vessel always displaces its own weight in water. Theoretically, as long as the water level stays the same, when a boat floats over an aqueduct, there is no change in forces on the columns. The displaced water flows away, balancing the new force of the boat. Same thing for the gondolas. When a boat floats in, its weight in water flows out, maintaining a balance between the 2 sides. As a result, the Falkirk Wheel doesn't really require a lot of power to operate. It's about 1.5 kilowatt hours for a half turn of the wheel, often compared to the power required to boil 8 kettles of water. Where I live, that's less than 25 cents in electricity. And unlike the day-long climb of the Industrial Revolution-era locks, the wheel moves boats between levels in about 5 minutes. The Scottish canals see almost no commercial shipping these days. They're still too small, and the road and rail networks are still faster, but the canals do see a lot of traffic. There's a whole class of vessels specifically designed for navigating the unique and historic canals of the UK. Similar to RV culture in the US, narrowboats ply the inland waters across England, Wales, Scotland, and beyond, used for holidays, touring, and even as long-term homes. During the early Industrial Revolution, boats like this were pulled along canals by horses or donkeys from towpaths that ran alongside them. Modern narrowboats are self-propelled and often equipped with domestic comforts, including bathrooms, kitchens, heating, and internet. The number of boats has been steadily increasing over the past decade, offering the freedom and lower cost of a nomadic lifestyle on the canals. Even for those not living on narrowboats, cruises and tours along the canals offer something unique. It's a totally different way to experience the landscape in some of Great Britain's most beautiful areas, and it offers insights into the history of the region that you can't get anywhere else. And of course, you also get to see the fascinating infrastructure, including a boat lift that you won't find anywhere else in the world. But it doesn't go all the way up. When a segment of the canal was relocated as part of the Millennium Link, it needed to cross the Antonine Wall, a Roman-era defensive perimeter and UNESCO World Heritage Site. Rather than disturb it, the new canal was built into a tunnel below. From the aqueduct at the top of the wheel, 2 new locks raise boats the remaining distance once they pass underneath the wall to the top of the Union Canal. The Antonine Wall marked the far northern border of the Roman Empire. On another edge, just a handful of decades before it was built, Mount Vesuvius erupted, burying the city of Pompeii in ash. But there's a twist to that story. My friends at the podcast Radiolab are just about to premiere a fantastic video about the survivors of Pompeii and how we discovered that some people actually escaped. This simultaneous release is part of a collaboration with the Independent Media Initiative to highlight some of the best educational and artistic creators on the internet. I'm really thankful for the award the channel won this year for my practical construction special, and I'm so excited to hand off to one of my favorite shows on the internet, Radiolab, for the next video in this collaboration. Go check it out after this. When I was a kid, my dad used to tell me if the only reason you want something is because it's cool, you probably don't need it. You can look at me and probably tell that I took that advice to heart, but there are situations where it's worth doing something just because it's gonna be impressive. The Falkirk Wheel is a perfect example. Locks are a perfectly functional solution to get boats up and down to different elevations. There are thousands of them around the world diligently serving our inland waterways. Scotland wanted something special, something that would spark a resurgence in their canal system and revitalize the sense of pride in communities along them. It took guts to try something completely different, and it paid off. Millions of people have visited to watch it turn or travel through it. The Falkirk Wheel didn't just reconnect 2 canals, it reconnected people with the idea that infrastructure can be both useful and pretty cool. Here's something else that's pretty cool, a home-cooked meal that's seasonal, healthy, and didn't require a trip to the grocery store. We've been using today's sponsor HelloFresh for years now, even before these ones were born, and now they're actually old enough to help out with dinner. Kind of.
And some snail shells. Put them in the pot.
The idea is simple and perfect for us. Pre-portioned ingredients shipped right to your door so your dinner's ready to go.
It's burning.
These helpers can be a bit picky, but HelloFresh has expanded their options and even made them customizable to fit the preferences of the week.
Just put the pepper on Mommy's croutons though, because I like it spicy. These will be mine.
And in fact, HelloFresh has kid-friendly choices that are specifically curated for little ones that don't like to stray from the staples like I do.
Don't mind the man saying, "Oh no," repeatedly in the background.
Even beyond the good food, using HelloFresh is just a great way to spend time together. Having it as a kit like this makes it fun for the kids, keeps them involved, and I think makes them more likely to try new foods.
I'm cooking mushrooms on the stove.
Right.
Give a second chance to the new HelloFresh by using my code PRACTICALFM at HelloFresh.com for 10 free meals plus free breakfast for life. This part's verbatim. 1 free meal per box with active subscription, free meals applied as a discount on first box, new or returning subscribers only, varies by plan. Sign up today, click the link below or use my code PRACTICALFM at HelloFresh.com. Thank you for watching and let me know what you think.